Hello students, welcome back to the next lecture of Quadratic. So today, as we have said earlier, we are going to discuss graph and range of quadratic expressions. So first, graph of quadratic. See, y equal to ax square plus bx plus c. We want to draw the graph of this expression. So, if a is greater than 0, the graph of this quadratic will be an upward parabola. The graph of quadratic is a parabola. First, we need to remember that it is a parabola. Further, you will learn what is a parabola, why are we calling it a parabola. So this is a parabola. If a is greater than 0, then it is upward parabola, and if a is less than 0, then it is a downward parabola, where it is called vertex. V is called vertex. V is the vertex of parabola, and its coordinates are minus b by 2a minus d by 4. Y equal to ax square plus bx plus c. We can make it a perfect square. So the expression will be x plus b by 2a whole square So this is x plus b by 2a whole square plus b square minus 4ac upon 4a. Y minus b square minus 4ac upon 4a is equal to a times x plus b by 2a whole square. Okay. So this is a parabola, y equal to ax square type parabola, where y is equal to and x is equal to x plus b by 2. Equal to 0, vertex will be minus d by 4a and minus b by 2a. From here we can conclude that this is the equation of a parabola. If a is positive, upward parabola; if a is negative, then downward parabola. Okay. So for now, we need to remember the coordinate of the vertex minus b by 2a and minus d by 4a. Then we can draw the graph. If coefficient of x square is positive, the graph is upward parabola. If a is less than 0, then graph is downward parabola. Let's draw some graphs. X square minus 2x minus 3. We can see that a is equal to 1, which is a positive number. So vertex minus b by 2a minus d by 4a, 1 comma minus 4. So the graph will be like this. The vertex is 1 comma minus 4. This is the vertex, and the graph will be upward parabola. So how can I draw? I can draw it in various ways. The depth of parabola is not known to me. How can I draw? So I will check that at x equal to 0, the value of y is minus 3. So I can draw like this, because the graph will be symmetric about its vertex. So this will be our graph. The graph is cutting the x-axis at the roots of this equation are 3 and minus 1. This extra information we can write because we know the roots of this quadratic equation will be 3 and minus 1. So this is how we can draw the graph of a quadratic expression. Similarly, we can draw the graph of if a is less than 0. So why are we drawing the graph? From graph, we can see the range. We can solve the questions based on range of quadratic. Okay, so there are some observations. The graph is intersecting the x-axis at two distinct points because the equation have two distinct roots, because its discriminant b square minus 4ac is greater than 0. As discriminant is positive, we have learnt in nature of roots that if discriminant is positive, then the graph of quadratic equation will have two real and distinct roots. So there are two real and distinct roots. It means that the graph of quadratic will intersect the x-axis at two distinct points. So there are some observations regarding this. If discriminant is positive, then graph of y equal to ax square plus bx plus c intersects the x-axis at two distinct points. If d is equal to 0, then graph of quadratic touches the x-axis. Okay, because the roots are real and equal. In this case, there are two real and distinct roots. In this case, both roots are equal. So the graph will touch the x-axis. So two equal roots will be there. If discriminant is less than 0, then graph of quadratic neither intersects nor touches. Neither intersects nor touches. So if A is greater than 0, the graph will be like this. If A is less than 0, the graph will be like this, always above the x-axis or always below the x-axis. Okay, these are some observations based on the sign of discriminant. If sign of discriminant is positive, negative or equal to 0, the graph will behave with respect to x-axis like this. So as we are talking about the sign of discriminant, if graph of y equal to ax square plus bx plus c is given, can we determine the sign of A, B, C and discriminant D? So A and D we have already discussed. Okay, the question is the graph is given like this. This is the graph given and we need to determine the signs of A, B, C and D. Okay. So as the graph is upward parabola, we can say directly without any calculation, without any much practice, without any much exercise, we can say that A is a positive number as the graph is mouth opening upwards. Now the graph is intersecting the x-axis at two distinct points, so discriminant will also be positive. Now remains the signs of B and C. How can we check the sign of B and C? See, at x equal to 0, the value of y is c. So this point will be 0 comma c, as we are seeing that the value of c will be positive. The graph is intersecting the y-axis at positive y-axis, so the value of c will be positive. C is done. Now the sign of B. How can we determine the sign of B? B comes in the x coordinate of the vertex. X coordinate of the vertex is minus b by 2a and y coordinate is minus d by 4a. So minus b by 2a, if we are interested in minus b by 2a, can we check the sign of the x coordinate of the vertex? Vertex is lying in fourth quadrant. In fourth quadrant, the coordinate of x is positive. And we are clearly seeing that minus b by 2a in positive y-axis. So minus b by 2a will be a positive number. Now multiplying this by negative sign, b by a will be less than 0. Now a is positive, so b will be less than 0. Hence we can determine the signs of a, b, c and d. Hope this is clear to you. We can take one more example for determining the signs. Let's say the graph of quadratic is like this, and we need to check the signs of a, b, c and d again. So the graph is downward parabola, a will be negative, coefficient of x square will be negative, intersecting the y-axis at negative y-axis, so c will be less than 0. Discriminant is also less than 0 as the graph is neither intersecting nor touching the x-axis. And finally, the sign of b, minus b by 2a, the coordinate of vertex, x coordinate of vertex. Vertex is lying in third quadrant. In third quadrant, both the coordinates are negative. So minus b by 2a will be negative. So b by a will be positive. Now the sign of a is negative, so b will also be negative. So in this situation, all the signs a, b, c and d are coming out to be negative. So okay, so sometimes we need to check the signs of a, b, c and d. So this is the thing. This is how you can check the signs of a, b, c and d. Now coming back to the graphs, the graphs we are drawing again for various conditions of the signs of a and d. For a is greater than 0 and for a is less than 0, we are drawing the graph. A greater than 0, d greater than 0, the graph will be like this. And for a less than 0, the graph will be like this, intersecting the x-axis at two distinct points. For d is equal to 0, the graph for a greater than 0 will be like this, and graph for a less than 0 will be like this. Again for d is less than 0, the graph will neither intersect nor touch the x-axis, neither intersects nor touches the x-axis. Okay. So what I can see, that in this situation, I am determining now the sign of y, the sign of quadratic. If I am interested in sign of quadratic, that what will be the sign of y? As from the graph we know that the graph which lies above the x-axis, the sign of y is positive, below y is negative, positive, negative, negative, positive, negative. So I can see that there is only one case for d greater than 0, whether a is positive or a is negative. If d is positive, then the graph is, the value of quadratic is, the value of y is positive, negative, positive, positive as well as negative. The quadratic is changing its sign for d greater than 0 only. Similarly in this case, from negative to positive, from positive to negative. In all the other cases, either the quadratic always positive, non-negative, the quadratic is always negative, non-positive. So for a positive, d negative, the quadratic is always positive, it is not changing its signs. Similarly, for d equal to 0 also, the quadratic is not changing its sign. For a greater than 0, it is always non-negative. For a is less than 0, it is always non-positive. But in this case here only, the quadratic is positive, y is greater than 0 for x belongs to, let's say this root is alpha, this root is beta, union beta to infinity, and y is less than 0 from alpha to beta. In this case, y is greater than 0 for x belongs to alpha to beta and less than 0 for x belongs to minus infinity to alpha union beta to infinity. Here it is always greater than or equal to 0. Here it is always less than or equal to 0. Here it is always greater than 0. Here it is always less than 0. So many questions can be formed from this concept. First we write down our conclusions. If A is positive and D is negative, then ax square plus bx plus c is greater than 0 for all x belongs to R. Similarly, if A is positive and D is less than or equal to 0, then ax square plus bx plus c is greater than or equal to 0 for all x belongs to R. Similarly, for A less than 0, this is always negative. Okay. These are 4 observations depending upon the sign of A and D. Okay. And another observation was the quadratic changes its sign only when the sign of discriminant is positive. Okay. So let's do some problems. If roots of the quadratic equation ax square minus bx plus 1 equal to 0 are non-real, then show that a minus b plus 1 is positive, a plus b plus 1 is positive, 4a minus 2b plus 1 is positive, a plus 2b plus 4 is positive. More questions can be formed. Okay, so we are going to prove these 4 conditions. We are given that roots of this equation are non-real. If I say this is an expression, quadratic expression ax square minus bx plus 1 whose discriminant is less than 0. If roots are non-real, so according to the nature of the roots, a and b are given as real. So if discriminant is less than 0, then the quadratic equation will have non-real roots. We are given that the quadratic equation has non-real roots. So if d is less than 0, I am interested in the sign of fx. We are asked to, we have to prove the sign of these expressions. So we are interested in sign of quadratic. So what will be the graph of this expression? What type of graph will this expression have? D is less than 0. So the graph will neither intersect nor touches x-axis. Either it can be like this or like this. Either if A is positive, then like this. If A is negative, then like this. Now we are not given the sign of A. Coefficient of x square is A. We do not know the sign of A. So how can we determine which of the graph is possible? So we can say the value of fx at x equal to 0 is 1. At x equal to 0, the sign of quadratic is positive. And we already knew the discriminant is less than 0. So sign will never change, the quadratic sign will never change. At x equal to 0 it is positive, so I can say that it is always positive. I can say that it is always positive. So graph will be like this. This will be the graph of y equal to fx, which is greater than 0 for all x belongs to R. Now if I need to prove the first expression, put x equal to 1. If I need to prove the second expression, put x equal to -1. For third, put x equal to 2. For fourth, put x equal to -1. Similarly, more questions can be asked. In each case, for each value of x, the sign of quadratic will be positive. Hope this is clear to you. Let's move forward to another problem. If the expression kx square plus x plus k divided by 2x square plus x plus 1 is always positive, then find the set of values of k. Okay. So we are given that this expression is always greater than 0 for all x belongs to R. See, in the denominator the expression is always positive. The denominator is always positive. Why? Because for the denominator a is equal to 2 and d is equal to -7, which is less than 0. So in the denominator the quadratic is always positive. So for this expression to always be positive, kx square plus 2x plus k should be greater than 0 for all x belongs to R. Now condition for this is, see, if it is a quadratic equation, if k is quadratic, then if k is not equal to 0, then this is a quadratic expression, is a quadratic expression. So for condition for a quadratic to be always greater than 0 is the coefficient of a is greater than 0 and d is less than 0. So the value of k will be -infinity to -1 union 1 to infinity. K is greater than 0, so the value of k will be 1 to infinity. We cannot take the value of k is equal to 0. Okay, so which is not coming in this solution. If k is equal to 0, we need to check what will happen if k is equal to 0. We can directly check if k is equal to 0, then the expression becomes 2x. 2x is 2x greater than 0 for all x belongs to R? No. 2x is greater than 0 for x greater than 0. So k equal to 0 will not be the part of our solution. Okay. See, the condition for ax square plus bx plus c, which is a quadratic expression, to be positive is a is positive, d is negative. We do not know whether this is a quadratic expression or not. So we are considering both the situation. First, when it is a quadratic, k is not equal to 0. Second, when it is not a quadratic, k is equal to 0. For k is equal to 0, the expression is coming out to be 2x, which is not greater than 0 for every x belongs to R. Another problem we can say ax square plus 2ax plus 1 is greater than 0. If this is greater than 0 for all x belongs to R, then find the set of values of A. Okay. If this expression is greater than 0 for all x belongs to R. And again, we will have to check whether it is a quadratic of or not. If A is not equal to 0, then this is a quadratic expression. And if it is a quadratic expression, then for it to be always greater than 0, A should be greater than 0 and D must be less than 0. B square minus 4AC less than 0. The value of A lying between 0 to 1. A is greater than 0, so our answer will be A is from 0 to 1. But we have to check what will happen if A is equal to 0. Since we are not given that it is a quadratic, we are just given an expression where coefficient of x square is A, which can take any real value. And we need to find those real values of x where this quadratic is positive. So first we applied the condition of quadratic when a quadratic is always positive. So for this to be a quadratic, A cannot be equal to 0. Now if A is equal to 0, what will happen? This expression becomes 1, which is greater than 0 for all x belongs to R. Whether any value I can put, if A is equal to 0, this expression is always greater than 0. So A equal to 0 is also a possibility, is also the part of the answer. The final answer will be A belongs to 0 to 1, where 1 is in open bracket and 0 will be in closed bracket. So the set of all the values consists 0 also. So this we need to be careful. If the question was like that, if the quadratic expression this is always greater than, then in the question it has been said that this is a quadratic. So we need to take A is not equal to 0. But here only an expression is given. Okay. So this is the part where you need to be very careful. So next topic is range of quadratic. So we have already learned how to draw the graph of quadratic. From that we can see the range. Suppose A is greater than 0, so the graph will be like this. First we need to learn what is the meaning of range. The range is the value of y. Range of quadratic means y is equal to x square plus bx plus c. Range of quadratic means the values of the set of values which y can take. So I can see from the graph that minimum value of y is minus d by 4a, maximum is infinity. So the values y can take are minus d by 4a to infinity. This is for a greater than 0. For a less than 0, the graph will be like this and maximum value of y will be minus d by 4a. So range will be minus infinity to minus d by 4a. If a is positive, minimum value is minus d by 4a, maximum is infinity, so range will be minus d by 4a to infinity. Similarly, if a is less than 0, maximum value will be minus d by 4a and minimum value will be minus infinity. Minimum is minus infinity, so range will be minus infinity to minus d by 4a. Okay, so this is quite simple, but what we are asked to find the range in a restricted interval. This is the range for x belongs to R. Range in restricted interval. Suppose we are given to find the range of this for x belongs to x1 to x2. We need to find the range of this quadratic, but for not x belongs to R, for not all the real values of x. We have to find the range for x belongs to x1 to x2. First we will see what can happen. Let's say x1 and x2 are somewhere here. So the range will be the value of y at this point and the value of y at this point. This is y1, this is y2. So the range will be y1 to y2. If x1, x2 lies here, then minimum value of y is at x2, which is y2, let's say, and maximum value is at x1, let's say it is y1. So range will be y2 to y1. But if x1, x2 are here, then this is the value of y at x equal to x1, this is value of y at x equal to x2. But here in this graph, the minimum value is neither y1 nor y2. The minimum value is minus d by 4 and maximum value is y2, the value of y at x2. So either we can always draw graph and shade the portion of the graph in that interval where the range is to be found, or we can devise a process, we can make a working rule to solve these type of questions. So what I will do, first find the value of minus b by 2a. If minus b by 2a is lying between x1 to x2, see, if minus b by 2a, the x coordinate of vertex, is between x2 to x2, we are considering this situation, that this minus b by 2a is in between x1 to x2. Either the graph can be upward or can be downward. We are taking both the situations. So this is a working rule. If minus b by 2a belongs to x1 to x2, then range will be minimum of minus d by 4a, value of y at x equal to x1, value of y at x equal to x2, to maximum of minus d by 4a and these two. This will be the range. What we will do, if minus b by 2a lying between x1 to x2, we will find three values. Minus d by 4a, which is the value of y at minus b by 2a, the y coordinate of vertex, and the value of y at x equal to x1, the value of y at x equal to x2. Whatever will be the minimum of these three will be the smallest value of y. What will be the maximum value of these three will be the maximum value of y. So the range will be minimum of these three to maximum of these three. If minus b by 2a does not lying between x1 to x2, then you find only two values, the value of y at x1 and value of y at x2. Range will be minimum of x1 x2, y x1 y x2 to maximum of y x1 and y x2. Okay, so in this situation we do not need to find the y coordinate of vertex, we do not need to find the minus d by 4a value. Okay, so the range will be minimum of these two to maximum of these two. From one example we can understand. Suppose we need to find the range of for first part is x belongs to, let's say first part is for x belongs to R, second part is x belongs to minus 1 to 2, third part is 2 to 3, minus 2 to 0. Okay, 0 to 3. So for x belongs to R, this is quite simple. The value of y will be minus d by 4a to infinity, which is equal to minus d by 4a is minus 4, so y will be equal to minus 4 to infinity. First part is simple. Because the coefficient of x square is positive, the minimum value will be minus d by 4a, so minus 4 to infinity. Now, for x belongs to minus 1 to 2, first find the value of minus b by 2a, which is 1. Is 1 lying between 1 to 2? Yes, 1 lies between minus 1 to 2. So we need to find 3 values. First minus d by 4a, which is minus 4. Then value of y at x equal to minus 1, which is 0. And value of y at x equal to 2. 4 minus 4 minus 3. So the range will be minus 4 to 0, smallest to largest. The minimum of these 3 values is minus 4 and maximum of these 3 values is 0. We can also do this by drawing the graph. By drawing the graph, we can directly say the range. The graph of this expression is like this. Vertex is 1, comma minus 4. We also needed to find the values, because we need to find the values between minus 1 and 2. So at minus 2, minus 1, the value will be 0. At 2, at x equal to 2, the value is minus 3. So we need to see the graph between these 2 points, minus 1 to 2. Minimum value is minus 4, maximum value is 0. So this could be done using the graphs also. Similarly, we can do third and fourth, 0 to 3. For x belongs to 0 to 3. For x belongs to 0 to 3, minus b by 2a was 1, is lying between 0 to 3. Minus d by 4a is minus 4. The value of y at x equal to 0 is minus 3. The value of y at x equal to 3 is 0. So the range is minus 4 to 3. Sorry, this is minus 3. Minus 4 to 0. Again, the result is minus 4 to 0. In this situation, we are given to find the values from 0 to 3. So from 0 to 3, the minimum value is minus 4, maximum value is also 0. Fourth was minus 2 to 0. For x belongs to minus 2 to 0, the vertex minus b by 2 is not lying between minus 2 to 0. Okay, so we only need to find the value of y at minus 2 and value of y at 0. The value of y at minus 2 is 5. So the range will be minus 3 to 5. So any quadratic expression, the range of any quadratic expression can be found using this concept. Either it is a quadratic in trigonometric expression or a quadratic in another expression. Let's say we have to find the range of sin square x plus sin x plus 1. This can also be done using this concept, applying this concept. How? Let sin x equal to t. Convert this equation in quadratic in t. So y will be t square plus t plus 1, and from here I know that t lies from minus 1 to 1. For this question, you need to know that the value of sin x lies between minus 1 to 1. So I need to find the range of this quadratic in this interval. Now the process is simple. Find minus b by 2a, which is minus 1 by 2, is lying between minus 1 to 1. So minus d by 4a I need to find, which is 3 by 4. The value of y at minus 1 is 1. The value of y at 1 is 3. So the range will be 3 by 4 to 3, minimum to maximum. Any kind of quadratic expression. which can be converted in a quadratic polynomial, you can find the range. Okay, either it can be a quadratic in trigonometric expression, or let's say this expression. This is not a quadratic, this is a biquadratic, but it can be converted in a quadratic. Let x square equal to t. So the expression become t square minus t plus 1 equal to 0. From here we know that t lies from 0 to infinity. So we need to find the range from 0 to infinity. Apply the same concept. Minus b by 2a, half, lying between 0 to infinity. Yes, it lies between 0 to infinity. So minus d by 4a, which will be 3 by 4. Again, the value of y at 0 is 1, and the value of y as y approaches infinity, as x approaches infinity. As we put the value of t, if the value of t approaches infinity, y also approaches infinity. So minimum of these three is 3 by 4, maximum is infinity. Any expression, if it can be converted into a quadratic, then we can find the range of that quadratic expression. Suppose we need to find the range of this x, x minus 1, x minus 2, x minus 3. X is from 0 to 2, let's say 0 to 2. Okay. Now this is also biquadratic expression. So can this be converted into a quadratic? So this is a special type of biquadratic, which can take these type of some special types of biquadratic in our next lecture or next to next lecture. Here the coefficients 0, 1, 2, 3. The product, the sum, the coefficient x minus 0, x minus 3, 1, 2, 2 plus 1, 3, 3 plus 0, 3. What I can do, I can multiply these two, x square minus 3x, and multiply these two, x square minus 3x plus 2. Now if I consider x square minus 3x as t, then this will become a quadratic in t. See, we have converted this expression into a quadratic. Now we need to find the range of t. We need to find the expression where t belongs. So t is also a quadratic, and we need to find t when x is from 0 to 2. Similar concept can be applied. Minus b by 2a is 3 by 2, lying between 0 to 2. Yes, then we will find minus d by 4a, which is 9 by 4, minus 9 by 4. Value of y at 0 is 0. Value of y at 2 is 4 minus 6 minus 2. So the range t, the range of t is minus 9 by 4 to 0. So now we need to find the range of this quadratic when t is lying from minus 9 by 4 to 0. Again, same working method. Minus b by 2a is minus 1. Is it lying between minus 1 to 0, 9 by 4 to 0? Yes. Now we have to find the value of minus d by 4a, which is minus 1, value of y at 0, and value of y at minus 9 by 4. Minus 9 by 4, so 18 by 4. So the value will become 81 minus 72, 9 by 16. So range will be minimum to maximum, minus 1 to 9 by 16. This will be our answer. So any expression that can be converted into a quadratic, its range can be found using this concept. Find vertex, check whether it is lying between the range of that expression in which you have formed the quadratic, and you apply this concept. Minus b by 2 if lying between that, find minus d by 4a, and the extreme values, range will be minimum to maximum. If not, then only find the extreme values, range will be minimum to maximum. So the range of quadratic is done. Now we can learn about range of these type of expressions: quadratic by quadratic, linear by quadratic, quadratic by linear. All are in simplest form. Simplest form meaning no factor is common between these two expressions. The quadratic will have two factors, so and no factor is common. Similarly, no factor is common. So this is the simplest form where it is quadratic by quadratic, linear by quadratic, quadratic by linear. Okay, so let us take an example. Suppose y is equal to x square minus x plus 1 upon x square plus x plus 1. Find range of y for x belongs to R. Here no restricted interval is given. For x belongs to R, we need to find the range of this expression. So what we can do, we can convert it in a quadratic, cross multiply. Now this is a quadratic expression for y is not equal to 1. For y is not equal to 1, it is a quadratic, and this is a quadratic in x. The value of x is given as a real number, so the discriminant of this quadratic will be greater than or equal to 0. B square minus 4ac greater than or equal to 0. Solving this inequality, a square minus b square, a plus b, a minus b. Solving this inequality, we have come to the conclusion that y belongs to minus 1 by 3 to 3. But here we had applied the concept of a quadratic equation. We were considering y is not equal to 1. So we cannot take here y as value 1. Now for y is equal to 1, this expression becomes for y equal to 1, this expression becomes 0 plus 2x plus 0. So x equal to 0, at x equal to 0 y can take value 1, so y equal to 1 will be the part of the range. See, we needed to find the range of y, so all the values of y which it can take, so all the values which y can take. For using the concept of quadratic, we needed to say that y is not equal to 1, but if when we checked for y equal to 1, we found that y can be equal to 1 for x equal to 0, hence y can be equal to 1. We are finding a value of x where y can be equal to 1, so the range will be y belongs to 1 by 3 to 3. For y equal to 1, this was not a quadratic. For y equal to 1, this expression becomes this. For x equal to 0, y can be equal to 1. So in the range of y, 1 will be there. See, you will understand this by next example. If we are to find the range of x square plus 2x plus 3 upon x square plus 2x minus 1 for x belongs to real numbers, for permissible values of x, for all possible values of x, possible real values of x, because this expression is not defined for all x belongs to real numbers, denominator cannot be equal to 0. So again we cross multiply. So the expression becomes Okay. Now for y not equal to 1, d will be greater than or equal to 0, b square minus 4ac two y plus 2. So the range here will be minus infinity to minus 1 union 1 to infinity. There will be an open interval on 1, as we are taking y is not equal to 1, but we need to check whether y can be equal to 1 or not. So for y is equal to 1, this expression becomes 0 plus 0 minus 4, which cannot be equal to 0 for any real value of x. See, so first we applied the condition of quadratic by considering y is not equal to 1. We excluded y equal to 1 from the solution. But for y is equal to 1, we had to check for y equal to 1 what is happening at y equal to 1. So for y equal to 1, there is no any value of x at which y can be equal to 1. So we can say that in the range of y 1 will not be there, hence the solution will be, hence range will be the one we had calculated earlier, minus infinity to minus 1 close union 1 to infinity open. So if we are applying the condition of quadratic, discriminant or any other thing, then we need to first verify whether it is a quadratic or not. If it is a quadratic, then apply the condition of quadratic. If it is not a quadratic, then check separately that for those values where x coefficient of x square becomes 0, what is happening. So here at y equal to 1, no real value of x is coming, so we can say that y cannot be equal to 1. Okay, so this was the expression of quadratic by quadratic. Similarly, we can done some problems on linear by quadratic, quadratic by linear. Had already done range of quadratic in restricted interval, range of quadratic for all x belongs to R, for x belongs to real number, and x belongs to some interval x1 to x2. Then we were doing the range of quadratic by quadratic, quadratic by linear, linear by quadratic type of expression. We have done 2 examples of quadratic by quadratic. Let's take some more example and some more concepts. Find the range of x upon 1 plus x square. This is linear upon quadratic type of example. So for this, again we will apply the same concept. This will be a quadratic in x for x belongs to real number. If x is a real number, then the discriminant of this quadratic expression will be greater than or equal to 0. So y will be from minus half to half. We will have to check what will happen at x equal to 0, because this is, we have applied the concept of quadratic, assuming that this is a quadratic equation, y is not equal to 0. For y equal to 0, we can clearly say x is equal to 0. So at x equal to 0, we are getting y as 0. So 0 will be in the range. So this answer is correct. Let's take one more example. X square minus 4x plus 3 upon x square minus 2x. For all permissible values of r, for all permissible values of x. See, here x cannot be equal to 0 and 2. So whether x will be any real number which for which this expression is defined, we have to find the range of this expression. So again, we will apply the same condition. Cross multiply again this will be a quadratic. Now for y not equal to 1, if y not equal to 1, the discriminant is greater than or equal to 0. Now the quadratic expression we are getting, from that we will have to find the value of y, and we can see that this quadratic is always greater than 0. This is greater than 0 for every y belongs to R. Why? Because the coefficient of x square a is 1, that is positive, and discriminant is negative. And we have already learned that for a quadratic expression, if leading coefficient is positive and the discriminant is negative, then that quadratic is always positive. So we can say the range of this will be all real numbers, but we have excluded 1. So we will check for y equal to 1. For y equal to 1, are we getting any value of x? So for y equal to 1, we are getting the value of x as 3 by 2. So by putting x equal to 3 by 2, we will also get y equal to 1. Hence the range will be all real numbers. Y belongs to all real numbers. See, there is a concept behind. If we are getting quadratic upon quadratic or quadratic upon linear type of expression, and see, the zeros of numerator are 1 and 3 and zeros of denominator are 0 and 2. The numerator is getting 0 at x equal to 1 or x equal to 3, and the denominator is getting 0 at x equal to 0, x equal to 2. There is a concept that if between any two zeros of numerator, between 1 and 3, if there exists a 0 of denominator, here 1 and 3, 2 lies between 1 and 3. So between two zeros of numerator there exists a 0 of denominator, so its range will always be R. Its range will always be R. 1 and 3 it is 0, and at 0 and 2 it is not defined. So at 1 this expression is 0, at 3 this expression is 0. If we see the sign scheme, this expression will be alternatively positive and negative in these intervals. So at 0 plus this is negative, this will be minus infinity. At 2 minus this will be plus infinity. At 1 it is 0. At 0 plus this is negative, not defined, so minus infinity. At 2 it is not defined, as x belongs to 2 minus, from in the left of 2 it will be not defined and will be positive, so plus infinity. So we can say that range is already getting R. So we can say if between two zeros of numerator, if there exists a 0 of denominator, then the range will be R. This can also be proved. Let's say, let's take an example, and from this example we will prove the theory. Y is given at x minus a, x minus b upon x minus c. Show that y can take all real values provided c lies between a and b. If a is less than b, c is from a to b. If a is greater than b, then c is from b to a. That is, we are going to prove. How can we prove? Again the same concept, we will cross multiply. So this will become a quadratic expression, x square minus a plus b minus x plus y, a plus b plus y plus ab plus cy. Okay. Now the coefficient of x square is 1, which is not equal to 0. So discriminant will be greater than or equal to 0. B square minus 4ac is greater than or equal to 0. Now this will quadratic will become, we are making it as a quadratic in y. So a plus b square plus y square plus 2a plus by minus 4ab minus 4cy. So this will become a square plus 2y a plus b minus 2c plus a plus b whole square minus 4ab. This is a minus b whole square. Now we need to find the values of y. No, we are given that y can take all real values. So this expression can take all real values. So this is greater than or equal to 0 for all y belongs to R. This expression is greater than or equal to 0 for y belongs to R. This is a quadratic expression. This is a quadratic expression for which is greater than or equal to 0 for all values of the variable y. So now what concept we can apply? That discriminant of this expression will be less than or equal to 0. We have written already that if a quadratic is greater than or equal to 0, then its discriminant is either less than 0 or equal to 0. This concept we are going to apply. So d greater than or equal to less than or equal to 0, b square minus 4 ac less than or equal to 0. So this will be a plus b minus 2c square minus a minus b square. So this is x square minus y square, a plus b, a minus b. So this has become 2a minus 2c and 2b minus 2c less than or equal to 0. So this is a minus c, b minus c, c minus a, c minus b. So we can say that c will lie between, c belongs to either a to b or b to a, depending upon whether a is greater than b or b is greater than a. Now we had to prove that c lies between a and b, and we have proven, we have finally reached to a conclusion that c is from a to b where a and b are in closed brackets. So we have to check whether c can be equal to a or not, or c can be equal to b or not. If x is equal to if c is equal to a, for c equal to a, this expression will get cancelled out and we will get a linear expression y equal to x minus b. See, we have proved this thing that c is lying. If c is equal to a or c is equal to b, then what will happen? If c is equal to a, our expression will be x minus b, where x cannot be equal to a, this range cannot be range of y cannot be R. because for if x is cannot be equal to y, then y will not take the value a minus b. Similarly, if we take c equal to b, then y will be equal to x minus a, and x is not equal to b, so y cannot take the value as b minus a, so range of y will not be r. So we can say that if numerator and denominator are having some common factor, then range cannot be equal to r. So in this situation, c cannot be equal to a, and also c cannot be equal to b. So our answer will be c will lie between a and b. C cannot be equal to a and c cannot be equal to b. So this is the concept, that if this range of this expression is all real numbers, then between zeros of the numerator there exists a zero of the denominator. Okay. Let's take one more example. If range of x square minus ax plus b upon x square plus x plus 1 is 1 by 3 to 3, find AB. Okay. Now earlier we were finding the range of quadratic by quadratic expression. Now the range is given and we need to find some parameters a and b if the range of this expression is 1 by 3 to 3. Same working method, we will consider this expression as y, cross multiply okay. Now for y is not equal to 1, discriminant will be greater than or equal to 0. Discriminant will be b square minus 4ac minus 3y square plus 2y a plus 2b. A plus 2b plus 4 and a square minus 4b. This is greater than or equal to 0. Now if range is 1 by 3 to 3, this expression the roots of this expression. See, we plot on number line the zeros of this equation, and by considering the plus minus minus plus sign, we say the range will be from either minus infinity to minus alpha union beta to infinity or alpha to beta. Coefficient of y square is negative, so we can write this as less than or equal to 0. Now, if the zeros of this quadratic are alpha and beta, then range will be y belongs to alpha to beta. Now the range we are already given. What is the range? 1 by 3 to 3. So the roots of, we are given, now we can say that the roots of this equation are 3 and 1 by 3. Now sum of roots will be, we can write this equation on next page. A plus 2b plus 4 the roots of this equation are 3 and 1 by 3. Now sum of roots is 10 by 3, which will be equal to 2a plus 2b plus 4 by 3. So a plus 2b plus 4 is equal to 5. A plus 2b equal to 1. Product of roots minus a square plus 4b upon 3 is equal to 1. So a square plus 4b equal to minus 3. Solve these two equations and we will find the values of a and b. Check the expression y square minus by minus y. So this is y square plus 2ay plus a square minus 4y square plus 4b plus 4y minus 4b. So this is minus 3y square plus 2y. Okay, we have taken 2y as common. So this will be a plus 2b plus 2. And this will be a square minus 4b. Okay. So we can say that roots of this equation a plus 2b plus 2 are 3 and 1 by 3. So sum of roots equal to 10 by 3. A plus 2b is equal to 3. Product of roots is equal to 1. So a square minus 4b is equal to a square minus 4b upon 3 is equal to minus 1. So this will be equal to minus 3. Now solve these two equations, two unknown. put the value of B as, or put the value of A, 3 minus 2B, 9 plus 4B square minus 12B. So this will be 4B square minus 16B plus 12, B square minus 4B plus 3. B is equal to 1 and 3. Okay. So if B is equal to 1, A is equal to 1. If B is equal to 3, then A is equal to minus 3. Done? See, we have solved the equation that we are considering the roots of this equation are 3 and 1 by 3. So we have found the values of A and B as 1 and 1 and minus 3 3. Now check whether the range is 1 by 3 to 3 or not. 3y square minus 2y plus 2b plus 2 minus a square minus 4b is less than or equal to 0. For a equal to b equal to 1, this will become 6y minus plus 3. So y is 3y y square minus 2y plus 1. For a equal to b equal to 1, 2, 3, 4 minus 8y, a plus 2b. 3y square minus 10y plus 3. 3y minus 1, y minus 3, range will be 1 by 3 to 3. For a equal to minus 3 and b equal to 3, a equal to minus 3 and b equal to 3, this will become minus 3 plus 6 plus 2, 9 minus 12. So 3y square minus 10y plus 3. So range will be 1 by 3 to 3. So two values are possible, either a equal to b equal to 1 or a equal to minus 3 and b equal to 3. Okay. So we have done problems on quadratic by quadratic, linear by quadratic, quadratic by linear. Let's take the range of linear by linear. Linear by linear type of expression, we can directly remember that range of this is y belongs to all real numbers minus a by c. We can directly remember that. How? Let's say y equal to ax plus b upon cx plus d, cross multiply and write x in terms of y. So x will be b minus dy upon cy minus a. So we can say that y cannot be equal to a by c. We can directly remember that a linear by linear expression which is in simplest form, then range will be all real numbers minus the ratio of the coefficients of x, a by c. Y cannot be equal to a by c. Range of linear by linear cannot be all real numbers. It will always exclude this term a by c. Let's say we have to find the range of this expression. This is not a linear by linear expression, but we can always convert it by considering sin x equal to t. Now this is a linear by linear expression with the condition that the variable t is lying from -1 to 1. Okay. So the range of this expression will not be equal to r minus half. Why? Because that was true if x can take any real value excluding minus d by c, where denominator is getting 0. But here in this example, the value of t, the variable, can only lie between -1 to 1. So what we will do, we will write t in terms of y and the value of t is from -1 to 1. So we will solve these two inequalities. We will solve these two inequalities separately and find the value of y, the range of y. Similarly, y will be -infinity to half union 4 to infinity. Now we have to take intersection of these two. From first, the value of y is from -infinity to -2 by 3 union 1 by 2 to infinity. From second, it is from -infinity to half and 4 to infinity. Common of these three will be -infinity to 2 by 3 union 4 to infinity. This will be the range. Okay, you can check the calculations also. So when will the linear by linear expression comes handy in the questions on quadratic, range of quadratic? See, if we have to find the range of this expression, how we can proceed in this question? We cannot apply the condition of cross multiplication and then d greater than or equal to 0, that concept, because that was quadratic by quadratic in its simplest form. But this is not in simplest form. We are getting some common factors. In this we are getting a common factor as x minus 3. So this is not a quadratic by quadratic type of expression. This is a linear by linear because it is not in its simplest form. If we cancel out x minus 3, this will become a linear by linear expression where we will have to write that x cannot be equal to 3. We have cancelled out x minus 3 because we know that x cannot be equal to 3. Now the range will be y belongs to all real numbers minus 1 all real numbers minus 1, and also as x is not equal to 3, so y cannot take the value which is happening at x equal to 3. At x equal to 3, the value of y is 2, so y cannot be equal to 2. This we have to remember, this we have to consider, that in a quadratic by quadratic type of expression, one factor is getting cancelled out and the expression becomes a linear by linear. Then at this point where this is the common root is x equal to 3 in these two quadratics, so x cannot be equal to 3 as this is x equal to 3 in the denominator. By putting x equal to 3, we are getting y of 2. As x is not equal to 3, y cannot be equal to 2. So the range will be all real numbers minus 1 and 2. Let's do another very good problem. If the range of is R, find the set of real values of A. Okay, now the range is R. We have done this type of problem. The condition was between two roots of numerator there exists one root of denominator. But here roots will be found in terms of A. We will apply the same concept. Consider this as y. Now cross multiply. Five y minus A x square, 5x square minus 7a plus a and ax square minus 7x. Okay. Minus 7y x minus 1 y minus 1 plus ay minus 5. Now the discriminant will be greater than or equal to 0. (49y square minus 98y plus 49 minus 5ay square minus 25y minus a square y plus 5a. The coefficient of y square will be 49 minus 20a. y minus 98y and 100y. 100 minus 98, 2y and plus 4a square y. 4a square y plus 100 minus 98 and 49 minus 20a. 49 minus 20. All are done. All coefficients are done. This is greater than or equal to 0. Now 2y 1 plus 2a square plus 49 minus 20a. Now this is greater than or equal to 0 and we are given that range is R. So this expression is true for all the real values of y. Now if this expression is true for all the real values of y, then a will be greater than 0 and d will be less than or equal to 0. We know that for d equal to 0, the factors will common out, which we have done in previous problem, x minus a, x minus b upon x minus c. We will check here also. First apply the condition d is less than or equal to 0. So this will become b square minus 4ac, b square minus 4ac. This is 2a square plus 1 square minus 49 minus 2a square. A square minus b square, a plus b, a minus b, so this will be 2a square minus 20a plus 50, 2a square plus 20a minus 48. Take 2 common, a square minus 10a plus 25, this will be a minus 5 whole square. Take 2 common, this will be a plus a square plus 10a minus 24, a plus 12, a minus 2, less than or equal to 0. Now the solution of this inequality, all the values are less than 49 by 2a. So the solution of this inequality will be minus 12 to 2 union 5, okay, because there is a sign of equality, plus plus minus plus. So a will be minus 12 to 2 union 5. Now for the boundary conditions, if a is equal to 5, we will have to check. If a is equal to 5, the expression will become this expression. This expression will become, the expression is y is equal to ax square minus 7x plus 5 divided by 5x square minus 7x plus a. Now if a is equal to 5, this expression becomes 5x square minus 7x plus 5, 5x square minus 7x plus 5. Both roots are common. For this condition a equal to, actually this is the condition when both roots are, when there exists at least one common root. a1 minus a1 b2 minus b1 a2 b1 c2 minus b2 c1. This was the condition of common roots. So if a is equal to 5, both roots of these two quadratic are common, y is equal to 1, range cannot be R. So a cannot be equal to 5. Now for a is equal to 2, this expression becomes 2x square minus 7x plus 5 upon 5x square minus 7x plus 2. We can say that both these equations will have a common factor which is 1. Range cannot be R. So a cannot be equal to 2. Now for a equal to minus 12, for a equal to 2, one root common. For a equal to minus 12 also there will be one root common, you can check. Minus 12x square minus 7x plus 5 and 5x square minus 7x minus 12. Again for x equal to minus 1, common root is x equal to minus 1. So again range cannot be R, a cannot be equal to minus 12. The final answer will be a belongs to minus 12 to 2. If the range of the quadratic by quadratic expression is R, So from this point, if we are considering a greater than 0, d less than 0, you can directly remove the equality sign from here. D is less than 0, we will get the solution, because for d is equal to 0, you will get the condition, you will get the values of parameter a, the values where the numerator and denominator will have common roots. Okay, and if denominator and numerator have common roots, then range cannot be equal to r, which we have seen earlier. So this was the complete discussion about range of linear by linear, linear by quadratic, quadratic by linear, quadratic by quadratic type of expression. Okay, so let's conclude our lecture here. And in the last two lecture, we have learned everything about range of quadratic and quadratic type of expressions, rational expression involving quadratic and linear. So we will meet in the next lecture with some previous year question and some special type of biquadratic equations which can be solved using the concept of quadratic equations. Okay, so some special biquadratic equation and some previous year question we will take in the next lecture. Thank you.